Assalamualaikum and good day everyone. We are group 3 from 80127-A. My name is Nur Akila Batusha together with my group members Muhammad Iman Hasani, Fatihah Azmi and Kanisen Senin. Today we will present our practical assessment for AQU 139 Aquaculture Feed and Nutrition. The title of our study is Comparative Study on the Effectiveness of Fish Pellet made with two different sources of fish meal on the growth of Nile tilapia fry. This study compares the growth performance of Nile tilapia fry fed with pellets prepared using two different fish meal sources.
I will present our study on fish pellet formulation for Nile tilapia. Nile tilapia is one of the most commonly farmed freshwater fish because it grows quickly, adapts well to different environments, and is a good source of high-quality protein. Due to these advantages, it plays an important role in aquaculture and global food security.
Next, I will present about fish meal in fish feed. Fish meal is a protein-rich ingredient made from processed fish. It provides essential nutrients such as amino acids, fatty acids, and minerals that help fish grow faster and stay healthy. Traditionally, fish meal has been considered one of the best feed ingredients because it is easy to digest and supports strong growth. However, due to its high cost and sustainability issues, many farmers are now exploring commercial feeds as practical alternatives.
Next, protein in fish feed. Protein is the most important nutrient in fish feed because it supports body growth, tissue repair, enzyme production, and normal physiological function. Providing sufficient protein improves feed conversion efficiency, fish health, and growth performance. Since protein is also the most expensive component in aquaculture feeds, it is important to formulate diets that provide adequate nutrition while minimizing production costs.
For this study, we prepared 1 kg of fish feed using the ingredients shown on the slide. The main ingredients were fish meal, wheat flour, and palm oil. We also added CMC, bentonite, choline chloride, calcium phosphate, vitamin C, vitamin premix, mineral premix, and water. Each ingredient was weighed according to the pellet formulation before mixing. All ingredients were weighed according to the formulation. Next, all dry ingredients were mixed thoroughly before adding palm oil and water. The mixture was then processed using a pelletizer to produce pellets. After that, the pellets were dried in an oven at 40 degrees Celsius for 1 week. Finally, the pellets were turned every day to ensure they dry evenly.
Next, the method of preparing all materials and fish in the aquarium. To begin the experiment, we prepared aquariums to ensure a clean and safe environment. The aquariums were spacious enough for the fish to swim freely and were thoroughly cleaned to avoid contamination. We obtained tilapia stock from the hatchery, selecting only healthy fish with active movement and no signs of disease. Using a hand net, the fish were carefully transferred into the prepared aquariums filled with the treated water. Next, what is completely randomized design, CRD? Our experiment followed a completely randomized design or CRD. In this design, treatments are assigned completely at random so that each fish has the same chance of receiving any treatment. The factor tested was feed formulation. Class 81272-A used well-processed factory source fish meal, while class 81272-B prepared feed using fish meal from dead fish collected in the pond and hatchery. Each student was responsible for taking care of one fish.
Next, how do you weigh the fish? To measure fish weight, we use a digital weighing scale with a 250 ml beaker. First, the scale was switched on and the beaker placed on it. We pressed the zero button to ensure the beaker's weight did not affect the measurement. Then, using a hand net, the fish was gently placed into the beaker. The weight was recorded and the fish was returned to the aquarium. This process was repeated 3 times to obtain triplicate readings for accuracy.
Fish length was measured using 3 standard methods: total length, fork length, and standard length. The fish was cooked gently into a petri dish and a ruler was used for measurement. Total length is measured from the mouth tip to the end of the tail fin. Fork length is measured from the mouth tip to the fork in the tail. Standard length is measured from the mouth tip to the end of vertebral column before the tail fin. Measurements were taken quickly to minimize stress before returning the fish to the aquarium. But for this experiment, we don't take fork length measurement.
Next, how do you label the aquarium? We use the pen marker and masking tape to label aquarium. We write our name on the label aquarium. How do you prepare the water quality? To prepare the water quality, we use anti-chlorine to dechlorinate tap water. The treated water was left overnight with aeration to help the anti-chlorine dissolve faster. This ensured the water was safe for the fish and ready for use in the experiment.
Several water quality parameters were monitored throughout the experiment. Dissolved oxygen was measured using a DO-meter, as low oxygen can cause stress and mortality. Temperature was checked with a thermometer, since it affects metabolism and feeding. pH was measured with a pH meter, because extreme value can increase ammonia toxicity. Salinity was measured with a refractometer, and ammonia was tested with calorimetric kits, as high level are toxic to fish.
Next, record the fish data in the Excel provided in the Google Classroom. Weekly fish sampling data were recorded in an Excel sheet provided in Google Classroom. Fish weight was entered along with pellet requirements, calculated using FCR. If a fish died, the cause and symptoms were noted. A new fish was introduced to continue data collection. The Excel sheet included columns for weight, average weight, number of fish, total weight, length, and observations.
Next, method sampling week 1 to week 5.
Next, I will explain the fish sampling procedure. First, we prepare all the equipment needed. Then, we gently caught the fish using a hand fish net to reduce stress. After that, we weighed the fish using a digital weighing scale and measured its length using a ruler. Once all the measurements were taken, we carefully returned the fish to the aquarium. Finally, we recorded the fish weight and length in Microsoft Excel for data analysis. I will explain the proper way to scoop fish. First, move the net slowly and avoid chasing the fish because this can cause stress. Then, scoop the fish from underneath and lift it gently. After that, place the fish into a bucket containing pond water. This method helps reduce stress, prevent injuries and scale damage, and keeps the fish active throughout the sampling process. Next, I'll explain how to handle fish with less stress during sampling. First, always wet your hand before touching the fish to protect its mucus layer, which helps prevent infection. Second, minimize handling time to reduce stress. Third, keep the fish in pond water as much as possible to maintain its oxygen supply. Finally, return the fish to the pond quickly so it can recover faster. After weighing the fish, we recorded the data in Excel spreadsheet. First, we opened the Excel file from Google Classroom. Next, we entered the fish number followed by its weight in grams. After checking that the data was accurate, we saved the file and uploaded the completed Excel sheet back to Google Classroom. This helps ensure the fish growth data is recorded accurately and organized for further analysis.
Final sampling. In this experiment, fish sampling was done step by step. First, equipment such as digital scale and beakers were prepared. Fish were caught gently using a hand net, then weighed accurately with the scale and measured for length using a ruler. After that, the fish were returned safely to the aquarium. Finally, all data including weight and length were recorded in Excel to track weekly growth.
This graph shows the weight gain of fish fed with diet 1 and diet 2. Overall, fish fed with diet 2 gained more weight than those fed with diet 1. The biggest difference can be seen in fish 4, where diet 2 recorded 4.51 grams, while diet 1 recorded only 2.17 grams. This indicates the diet 2 promoted better growth performance. The average weight gain for diet 1 was 1.27 grams, while diet 2 achieved 2.26 grams. Although diet 1 used commercial factory fish meal, diet 2 still showed better growth. This may be because each fish responds differently to feed and utilizes nutrients differently. In addition, vitamin C may have degraded during the drying and storage period. Since the vitamin was sprinkled manually, it may not have been distributed evenly among the pellets. These factors may have influenced the growth performance observed in this study.
This graph shows the total length gain of fish fed with diet 1 and diet 2. Overall, fish fed with diet 1 achieved higher length gain than those fed with diet 2. Diet 1 recorded value of 2.1 cm for fish 1, fish 2, and fish 3, while fish 4 recorded 1.9 cm. In comparison, diet 2 recorded 1.4 cm, 0.5 cm, 0.9 cm, and 0.5 cm. This result indicate that diet 1 produced the best growth performance, whereas diet 2 showed the poorest performance, especially for fish 2. Therefore, Diet 1 was more effective in promoting fish growth during the experiment. Based on our findings, Diet 1 showed the best growth performance with an average total length gain of 2.05 cm, which was almost twice the growth achieved by Diet 2 with only 1.08 cm. This indicates that Diet 1 provided a more balanced and complete nutritional profile, adequate level of protein, lipids, vitamin and mineral, improve feed utilization, support tissue development and promote overall fish health, resulting in better growth performance. This finding is supported by previous study which reported that nutritionally balanced diet provide the amino acid needed for muscle growth, while lipids supply energy for metabolism. As a result, fish can use nutrients more efficiently and achieve greater length gain. In contrast, Diet 2 showed the poorest performance with an average length gain of only 1.08 cm. This lower growth may be due to inadequate nutrient levels, poor feed digestibility or reduced feed intake. When fish do not receive enough essential nutrient, energy is mainly used for maintenance instead of growth, leading to slower body length increases. Previous research has also shown that poor quality diets or diets with insufficient protein reduce feed efficiency, protein synthesis and overall growth performance. In conclusion, Diet 1 was the most effective treatment, producing the highest average total length. Therefore, Diet 1 is recommended as the most suitable diet for improving fish growth and development.
Next, result on survival rate. This graph shows the survival rate of Nile tilapia fry after the 6-week feeding trial. The result shows that Diet 2 recorded a survival rate of 87.5, while Diet 1 recorded only 50%. This means that most of the fish fed with Diet 2 survived throughout the experiment, indicating that this diet was more effective in maintaining fish health and reducing mortality. A higher survival rate suggests that the feed provided sufficient nutrients to support normal growth, strengthen the immune system, and help the fish cope better with environmental stress. In contrast, the lower survival rate in Diet 1 may have been influenced by lower feed quality, inadequate nutrient intake, or higher stress experienced by the fish. Overall, Diet 2 showed the best survival performance and is considered the most suitable diet for improving fish health and survival in aquaculture production.
Conclusion of the best performance of fish meal. After 7 weeks of rearing Nile tilapia, fish fed with Diet 1 showed greater body length but lower body weight compared to those fed with Diet 2. At the same time, the survival rate of fish fed with Diet 1 was lower than Diet 2. These findings suggest that Diet 1 promotes more linear growth but compromises survival, while Diet 2 supports heavier mass gain and better survival. Overall, Diet 2 is more suitable for aquaculture production because it provides both higher weight and improved stock sustainability.
Next, several challenges were encountered during this experiment. First, producing pellets with a uniform size and shape was difficult because some pellets broke during pelletizing. Second, fish handling during sampling required extra care because the fish were active and easily stressed. Another challenge was maintaining good water quality as leftover feed and fish waste was affecting fish health. Finally, measuring the feeding rate every week based on 3% of body weight was time-consuming. These challenges were managed through careful handling, regular monitoring, and proper feeding practices.
For the future directions of this study, there are 4 recommendations. First, test different pellet formulations to find the best nutrition for fish growth. Second, use alternative protein sources to make fish pellets more affordable. Third, develop sustainable fish feed using local ingredients while maintaining good quality. Finally, study pellet digestibility to improve nutrient absorption and reduce feed waste. Overall, these recommendations can help produce better and more sustainable fish feed.
Next, the implication of the study. This study helps us understand sustainable aquaculture practices and the importance of responsible fish farming. It also highlights the need to protect the environment by monitoring water quality and maintaining healthy ecosystems. Overall, this study provides a strong foundation for supporting sustainable aquaculture and environmental conservation. Building on these findings, we learned how to apply best management practices to reduce pollution in aquaculture. These studies also shows and emphasizes the importance of ecosystem-based management and the role of research and technology in supporting sustainable aquaculture. Based on this assessment, I believe my practical skills were enhanced. It improved my observation and data collection, strengthened my problem-solving skills, increased my confidence in applying aquaculture knowledge, and developed my teamwork and communication skills. Overall, this assessment prepared me to apply what I learned in real-life situations.
In summary, this project compares the growth of tilapia fry fed with 2 different fish meal diet over 2 months. The fish are fed daily while their growth, survival, and water quality are monitored weekly. The result will help determine which diet provides better growth and supports sustainable aquaculture practices.